All right, on 208, number 33, the question asks you to use your graphing utility to graph the quadratic function and then identify the vertex and the x-intercepts. So first thing you have to do is pick up your calculator and type it in. And then once you do, if you look at the graph, you can see it there in the mostly in the first quadrant and a little bit down into the fourth. So you can see the x-intercepts, there's 2, and then you can see the vertex down there. And if you look at the table, you can identify the lowest point for the vertex is 4, -1, and I got that from looking at the table. Then I look back at my graph, and that seems about right. Now the other thing you can do is now use the trace button, which is one of those buttons up there on the calculator, the trace button right there, and trace along the curve for the y-intercepts. And when I did that, I got 3.2, 0.3, which is, that rounds to 0, right? When I cross the x-axis at a number, I want the y to be as close to 0 as possible. So one of the intercepts is that, and the other one is 4.6, 0.07. Again, that rounds to 0. So that's what you can come up with using your graphing calculator and the trace function. Now, the textbook also said to check your results using algebra and completing the square. So how do you go about doing that? Well, let's take this equation. I'm going to rewrite it so that I can complete the square. So I'm going to take these two terms and factor out a 2, because complete the square only works if the coefficient of the x squared term is 1. Plus, I'm going to put a space there because that 31 isn't going to work, so we're going to keep the 31 out here and figure out what number I need to add here. And basically, I'm going to add the number here, and then I'll subtract it here so that I'm really not changing the value of the equation. I'm just making it look different. So, complete the square. That's kind of a no-brainer for you guys, right? Take the 8, -8, divide it by 2, and square it. So -8 divided by 2 is -4 squared, 16. So I put a 16 in here, which means I have to subtract the 16 here, but it's 2 times 16, so it's subtract 32. All right, let's rewrite this. I did complete the square for a reason. I did it so that I could factor that nicely. You know what that factors to, right? X minus 4, and plus 31 minus 32 is minus 1. When we get the equation in this form, what's the advantage? I know the vertex. It's the opposite of that number and that. This is the h and the k, correct? So the vertex should be 4, -1. And whoa, that's what I got when I looked at my chart. So I know I have the correct vertex. So there you go for the vertex. So we found the vertex algebraically, so now we have to find the intercepts algebraically. You remember how to do that? First, set the equation equal to 0, and then you try to solve it. And if you look at solving this one, it becomes quite obvious because it doesn't factor into 2 parentheses so that you could get 2 answers that way. So the quickest way is going to be quadratic formula. You remember that, right? So A is 2, B is -16, C is 31. And just plug those numbers in. So minus B plus or minus the square root of b squared, which is 16 squared minus 16 squared. That is b squared minus 4 times a times c all over 2a. And a was 2, so 2 times 2. So if I figure that out, and trusty old calculator, thank goodness I have it, we know we got a 4 in the bottom, we got 16 here, plus or minus the square root of 8. So this becomes 16 plus or minus 2 root 2 over 4, which becomes, 4 into that is 4, plus or minus 1/2 root 2. So that means the intercepts are 4 plus 1/2 root 2, 0, and 4 minus 1/2 root 2, 0. And if you check these out compared to the numbers I got off the graphing calculator, they're pretty close. So we found the answers to this problem a couple ways. We used the calculator and then we used algebra. I like the algebra a little bit better because you know you're getting a pretty exact answer, and sometimes reading off the calculator is not as easy to do. So you try a few of these.